Well, at the onset, it's probably well to remember the point that's already been made before in a prior lecture, that we don't transition in a linear and monotonic fashion from designing to then figuring out, well, how do I make it and what components might I use? But rather that design is very much and very, very strongly enforced by our own knowledge of manufacturing processes and components. Now, of course, we already looked at commercial off-the-shelf components, and now it is time to turn our attention to manufacturing resources. Okay. Just before we do so, I do want to say a few words about where fabrication steps into the design cycle. Where are we likely to find it, and how should we consider it, depending on where we are. Okay. So we already know that we transition from a set of specifications, of course, to then some conceptual design, down select, detailed design, and then ultimately we need to transition into manufacturing. Okay. So you can argue that there are 4 places in there where fabrication has a role. Okay. And they map roughly in this fashion. So you would see a need for a model when you are in the conceptual stage, in the early stages. You would see a role in there for a more formal prototype, let's call it, in the detailed design phases. And again, there's some overlap in between these. And then as you proceed, to the manufacturing launch, then you would find a place for fabrication in short-run manufacturing, as it is called, which is you can think of as manufacturing validation, prior to release into, of course, full production, which would be the last stage of the design cycle. Okay. Now, for each one of these phases, we have different needs from a fabrication perspective. When we are working with models, we really want a description of what our idea looks like. Okay, and we'll explain this a little bit more in detail in just a minute here. Okay, at the prototype level, we're looking for a works-like type of fabrication support, and then as we proceed into launch, okay, for short-run manufacturing, we want to see the manufactured-like fabrication processes, and then finally, of course, in full production, we want the real thing, which is suitable for the volumes that we're seeking. Okay. So let me say just a few words about each one of these steps so that we understand what they mean. So first of all, the model level, the purpose of a model, and this is, there's a subtle distinction between a model and a prototype. The purpose of a model is to convey a concept and to investigate perhaps isolated features, okay, of our impending creation. Okay. Models are done in very, very low quantities, and they can be both digital, in the sense that they can just live in a computer, or they can be done with hardware. Here are some examples. Rapid prototyping, okay, so that would be an example of a model. Okay, we also see examples of computer models in there on the top right and in the middle there, even mathematical models. A visualization can be thought of as a useful model, as can be some manner of visual simulation. So that's what we have there on the bottom left. Okay, and there in the middle left, we'll see a very, very simple model made out of wooden components. I would even say you can use cardboard, you can use foam board, you can use really anything that's appropriate to your purpose. Remember that a model is just getting the concept across, or at the very most, rifle shooting a very particular isolated feature so that you can gain confidence in it and proceed to the next stage. Now, at the prototype level, we're seeking to demonstrate or test a concept. We're talking about single-digit quantities and something more substantial than what we would see with a model. So here you see some pictures of examples of a model. Up there on the upper left is a more detailed embodiment, but still on the computer, of what a particular machine would look like. Okay. On the upper right, you see a prototype of a manufacturing process. So this is prior to short-run manufacturing and prior certainly to full production. And down there you see a camera that has some components in there, and decidedly not at the production level, you should hope, insofar as this is going inside a human body, but rather just at the level of something that enables us to understand and prove the concept. So at the prototype level, the fabrication choices and the fabrication demands become different. So here, instead of using very rudimentary materials, we might want to be a little bit closer to what the final product would be. Now, if there are elements of the final product that call for a an expensive or a sophisticated material, but they can be substituted for purposes of the prototype with a less expensive, more easy to obtain, more easy to machine material, then certainly that would be to our advantage. The important thing here is to make sure that you select a fabrication process that is serving your purposes, whether it be at the modeling stage, at the prototyping stage, or later. Now, as your prototype proves its worth, as the detailed design starts converging on a part that is going to be released for production, we will enter the so-called short-run manufacturing process. Okay? So here the point is to do not a proof of the product, but rather a proof of the manufacturing. We're talking about production runs in the order of tens, perhaps, or hundreds of parts. We're talking about a non-trivial capital commitment. Okay? However, not yet a full commitment to manufacturing, to full production. So here again, you will find manufacturing processes that depart from the previous stages of prototype and modeling. Okay? So you might have things like, for example, low volume injection molding, urethane casting, other processes that we will look at and classify here in the next video lecture. Okay. We're certainly going to be looking at final form, custom engineered components here. And we allow for the possibility of manual assembly in short run. Okay, so short run, again, we're proving the manufacturing, validating the key manufacturing processes before we go into full production. Some of those at this stage may still be manual in nature. Now finally, we'll get to full production. And that is, of course, a completely different game. Production, we're talking about full production, we're talking about now mass manufacturing. We're talking perhaps in the thousands of units, tens of thousands of units. Naturally, this will depend upon the specific component. We're talking about significant, substantial capital commitments. We're talking about setting up supply chains, deciding on our outsourcing strategy, perhaps greenfielding a facility, or at least finding one that we can use, that we can purchase, lease, in order to manufacture our product. We're talking about staffing that facility. We're talking about managing the facility in earnest, large capital expenditures, okay, scheduling, quality control, shipping and receiving, all these items. Okay. Now here, of course, the typical processes for mass production are going to be rather different from prototype and model, but hopefully short run will have already allowed us to identify the important processes, stable processes that we can rely on for the manufacture of this product. Okay. And then we might bring in some manner of automation in the manufacturing, perhaps semi-automation, semi-automated processes, or fully automated processes. Okay, so this is sort of the landscape. And again, to mention one more time, we should pick fabrication processes that are consistent with our need at each stage. Okay? So now let's find out what our catalog of processes looks like, what we have to choose from, and truly gain a good understanding of what those are, so that we know how to best design with them and use them in the right way.